welcome to my online teaching platform. In this video, we shall consider another aspect of application of differentiation, which is small change. Small change, all right? Now, if you have a function, let us take our function to be the area of a circle, which is area is a function of the radius, right? Pi r squared. Now, if you have the radius of a circle, okay, if you have a radius of a circle to be 2 centimeters, and this radius has now increased to 2.01 centimeters. All right, because there's a change, but the change is very, very small. Okay, now if you are asked to find the corresponding change in the area as a result of an increment, a small increment in the radius, how do you go about it? All right, so in this case, we are not going to use calculus. We use the normal way of getting the answer. So the first thing is you have to find the area of the circle with the initial radius, which is a. So you can say that a1 is equal to 22 divided by 7, which is the pi. So we are taking pi to be 22 divided by 7. Then times the initial radius, which is 2, having an exponent of what? 2. So our first radius will be 22 times 4. So 22 times 4 divided by what? 7. And this will give us a result of 12.57. All right, 12.57. Okay. Now, let us now find the area of the circle when the radius has been increased to 2.02. All right, so that becomes the second area. So the second area will be the same formula, 22 divided by 7 times times r squared, and our r now is 2.02. All right, because it has been increased to 2.02. So there's a small increment. First it was 2, but now it's 2.02. All right, so our new area, the second area will be, okay, there should be a squared over here. All right, 22 times 2.02 squared divided by what? 7. So you are going to get 2.02 squared, right, times 22, then you divide the result by 7, and that will give us a result of 12.82. All right, result of 12.82. All right, I'm leaving the answers in 2 decimal places. So if you want to know the corresponding change in the area when the radius is increased from 2 centimeters, the radius from 2 centimeters to 2.02 centimeters. We now want to know the increment that has occurred in the area. Okay, now the change in the area, this is how we find it. So change in the area will be the final area because of the increment. So the second area will be bigger than the first one minus the initial one. All right, which is the a1. That is the first area. Okay, in the first area we have, the second we have 12.82 minus the first area, which is 12.57. All right, so we are going to now determine our change in the area. So let us find the change that has occurred in the area as the radius increases from 2 to 2.02 centimeters. So it's going to be 12.82 minus 12.57. All right, and you are getting a result of 0.25. All right, 0.25. So this is the change that has occurred in the area. All right, when there has been a small increment, when there has been a small increment. Okay, when there have been a small increment from, that is in the area from 2 to 2.02. Now we can equally use calculus or the concept of differentiation to find the small change that will occur in the area as a result of a small change in the radius, right? So this is what you are going to use. So you have to get the same answer. You get the same answer. Then after that, when we have any small change, we are not going to use this formula again. Where you find the first area, if it's about volume, you find the first volume. Then you also look for the second volume after the increment before you find the difference. That one will be very long. But when it comes to calculus, you can equally get the same answer without following these steps. So let us look at how we can use calculus. So we have the formula for area to be pi r squared, all right? So we are going to find the change in A as a result of a small change in what? R. So this is change in A with respect to what? R is approximately the same as a small change in what? A as a result of a small change in R. So this is the formula that we use. So we are going to get dA dr is equal to small change in A divided by small change in what? R. You can equally use different symbol. So they all represent the same thing. Somebody can equally use the A, the R equal to this also change. So change in A over small change in what? R. You are going to get the same answer. But I prefer this one. Just that one is a capital letter and one is a lowercase. All right. Now, let us see if you are going to get the same answer. Using this first question, we are given a circle with radius and initial radius of 2 centimeters, and the radius has increased from 2 to 2.02 centimeters. All right, good. Now let us see if we can determine the small change in the area as a result of a small change in the radius using the concept of differentiation. So the moment the question is on area of a circle, then we have to bring down the formula for finding area of a circle, which is area is equal to pi r squared. Then you now differentiate your area with respect to the independent variable because we have to find the A, the R. And we know that the area depends on the radius. So it's going to be the A with respect to what? R. And that will give us 2 pi R. Okay. This is 2 pi R. Then when you are done with this, you also work on your small change. You know ours, we are finding small change in A. You don't know that one. So let's find the small change in R. Okay, the small change in R will be the difference between the two radii. So it's going to be 2.02 minus 2.00. All right. And this will give us a result of 0.02. So this is a small change that has occurred in the radius. So using the formula, we have the A, the R is approximately the same as small change in A divided by small change in what? R. Okay. So we know our dA dr to be 2 pi r, then equal to small change in A. That's what we are looking for. Divided by the small change in R, which is 0.02. Okay. Then now we have to now replace our R here. So you are going to use the initial R value, that's the initial radius. So we know that the initial radius, that's the initial one, is 2.00. All right. So we need to substitute that value. So it's going to be 2 multiplying pi times 2.00 all equal to change in the A over the small change in the radius, which is 0.02. That is the difference between the two radii. So we are now going to multiply. So here we are going to get 4 pi equal to small change in A divided by 0.02. So we now cross multiply. We are going to get 4 multiplying 0.02 pi to be equal to the small change in what? A. And this will give us, let us now multiply this. We have 4 times 0.02. And this will give us a result of 0.08 times the pi, which is 22/7, all right, will be equal to the small change in A. So this times 22 divided by 7, all right. So the answer here is 0.25, all right, 0.25, which is in 2 decimal places, then which is same as the small change in A. So we conclude that the small change in A is equal to 0.25. This simply means that when the radius of the circle increases from 2 to 0. From 2 to 2.02, okay, this is the change that has occurred in the area as well. So you will say that the radius increased from 2 to 2.02. So the increment was 0.02. And as a result of this, the area also increased by 0.25. All right, so that's the meaning. And let us go back and look at the basic approach that we use. That's why you need to find the area using the 2 radii. Then you subtract the area of the second one because of the increment from the first one. Right? I think we have used that one here. Let's go back. Okay. And you can say the answer is the same as the calculus approach. So when the change is very, very small, then the calculus approach will work. But when the change is very big and you use the calculus approach, it's not going to give you the same answer. So that is why the concept is termed as a small change. We are focusing on only a small change, okay? We are just focusing. So let me put a small change over here. Okay, good. So we are going to answer more questions in terms of how to apply the concept of a small change. Okay, and after that, we also look at percentage error. Okay, and those things. So we know that percentage error is error over the original times 100%. So we are going to apply some of the things that I've learned in commerce under percentages when we continue to answer more questions under this. So this is just the introduction to the concept of small change as one of the aspects of application of differentiation. Bye for now. And I hope you really enjoy the lesson. Please do not forget to share my videos with others to also follow or subscribe to my YouTube channel, which is Maths with MFA. Thank you for watching. Bye.